Okay, guys, all I want to do for this packet on vocabulary for Unit 2 or Chapter 2 is just kind of show you the pictures and the symbols we want to use for all of these logical implications and logical reasoning. All right, these are not in the order we're going to learn them, so they're in alphabetical order. Okay, first of all, biconditional. This is found on page 87 of your textbook. And I just want to show you the picture, or the symbol, the word biconditional, and I'm going to say it in words. So the picture is P, and you get a double arrow, Q, and this double arrow means if and only if and only if. This is read P, if and only if Q, or P, IFF, which stands for if and only if Q. So this is a biconditional. P and Q can be interchanged and can be read both ways. So you could also say Q if and only if P. Okay, in a conclusion, the conclusion of a statement is it's the last part of the if and then statement. So an if and then statement says this. This is the symbols. This means if P then Q. By the way, this is a conditional statement, so let's just go right ahead and write this for conditional. This means if P, comma, then Q. So because this means that then Q, the Q part is the conclusion. So the conclusion is the Q statement. Alright, so if P, then Q. P is the hypothesis, Q is the conclusion. Okay, I want to just kind of go back and talk about what a conjecture is. A conjecture is coming up with an answer based on a pattern. So, for example, Mrs. Van Torn, you notice Mrs. Van Torn comes in the building at 7:30 on Monday, and then you notice she comes in at 7:30 on Tuesday, and then you notice she comes in the building at 7:30 on Wednesday. So you're going to make a conjecture that Mrs. Van Torn is going to come in the building on Thursday at 7:30. That doesn't mean that I'm going to for real, but based on the pattern, your conjecture is I'm going to do that. So there is no picture and no symbols for a conjecture. There is nothing that we have. Okay, next page. Let me move this down so you can see it. All right, first of all, a contrapositive statement. A contrapositive statement, this actually comes from Chapter 5, one section in Chapter 5. So this is actually found on page 280 of your textbook. Converse is found on page 81 of your textbook. We're going to learn this in section 2.1. Counterexample. A counterexample is found on both page 5 and 81. And we'll get to deductive reasoning shortly. So there are some symbols for contrapositives, and a contrapositive looks like this for symbols. It has a squiggly, an arrow, and another squiggly, and this is read not Q, implies not P, or if not Q, then not P. If not Q, comma, then not P. Means the same thing mathematically, so it's important to know how to write the symbols and the words. Okay, a converse, you take a regular conditional sentence and you flip-flop it. So a conditional was if P then Q. The converse is if Q then P. So it's read if Q, then P. I just switched my letters around. Converse. Okay, to give a counter example, the word counter means to go against. You come up with an example to go against the statement to show it's false. Come up with an example to go against or show a statement is false. An example of a counterexample for me would be this. If I said, if x squared equals 16, comma, then x equals 4. Now, you think it's true, but this is false. So I'm going to write false, and now I have to provide a counterexample why it's false. So my counterexample is x equals -4. So what they're saying is x equals 4 is the only conclusion you can make. So if x squared equals 16, then x equals 4 is the only conclusion you can make. But that's false, because another conclusion you could make is that x equals -4. So I've provided a counterexample to tell why this statement is false. Okay, deductive reasoning. Last one on this page. Deductive reasoning, by the way, is found on page 94. And inductive reasoning is based on patterns. We learned about inductive reasoning. But deductive reasoning is coming up with conclusions based on facts. There is no picture I can provide, and there's no symbols. So no picture or symbols can be given for deductive reasoning. All right, next page, page 3. We talk about equivalent statements. Equivalent statements. Equivalent statements comes from chapter 5, section 5.4. Actually, it's on page 281. So page 281 is equivalent statements. And the hypothesis for a statement is actually found on page 80. Hypothesis is found on page 280. Inductive reasoning we learned in chapter 1. I'm just putting this on here to help remind you what inductive reasoning is, which is coming up with reasoning based on patterns. And lastly, inverse is found also in chapter 5, section 5.4 on page 280. Okay, I want to give you symbols for the ones that I can give to you so you know how to write them in your packet. Okay, for equivalent statements, an example of equivalent means equal. So two statements that are equal would be these. If I gave you a conditional, P implies Q, or if P then Q, and it's contrapositive, which is not Q implies not P. It turns out these are equivalent statements. They mean the same thing. So equivalent statements. And later on we'll give examples of these in class. All right, the word hypothesis. In a conditional statement, which is if P then Q, or if P then Q. The conclusion is the Q, the hypothesis is the P statement. So the P statement is the hypothesis. The P statement is the hypothesis. Okay, inductive reasoning we learned is a reasoning based on pattern, coming up with a conjecture based on pattern. based on a pattern. That's inductive reasoning. There's no picture for this or symbol. However, an inverse statement, there is a set of symbols for inverse statement, and an inverse negates a conditional statement. So a conditional statement is if P then Q, so the inverse is if not P then not Q. So it's read if not P, comma, then not Q. Or not P implies not Q. This is how you read the symbols mathematically. Okay, next page, page 4. All right, your law of detachment and your law of syllogism, these are provided right on the back of your vocabulary packet. So you can write these notes. As a matter of fact, you could just write C back of packet. So write C back of this packet. C back of this packet. And I just want to show you what I'm talking about. So the very last page of this packet, we have right here the law of detachment, and right here the law of syllogism. So you're going to they're already written for you, including the symbols, so you don't have to rewrite these because they're provided for you. Okay, so that's what I meant by see the back of the packet. All right, let's go backwards again. I want to talk about the word negation. The word negation, it basically means not. It means you're going to not do something. That's what negation is. So it's found on page 280. And the symbol for negation looks like this. It's that squiggly symbol. It's red, not P. So this symbol right here is a symbol for negation. All right, a theorem is a statement that you have to prove true. So theorem is a statement that must be proven true. The word for theorem, I'm looking in the back of your glossary statement. Let me find the word for theorem. It's on page 110. So the theorem is found on page 110, and it's a statement that, or a conjecture that has to be proven true. There is no symbol for it. An example would be vertical angles are congruent is our very first theorem, and we're going to have to prove that's true. So it's a statement that has to be proven true. Okay, so there's really no picture for theorem. You might want to write in words an example of a theorem, but there's no picture for it. All right, a truth value. The word for truth value is found on page 81, the definition. Truth value basically means true or false. That's what it means. True or false. Which we write T or F. So when it says provide the truth value, you've got to say, is it true or is it false? And if it's false, you always have to provide a counterexample to show why it's false, just so you know. All right, and lastly, a two-column proof. An example of a two-column proof is found on page 129. Basically, for a two-column proof, you're going to be given a given statement and what you're trying to prove. So you're going to say what you want to prove. We're going to do this by making statements. And here's my two columns, providing reasons why we can make these statements. So you're going to be given something you want to prove here, and you're going to give us a statement. Something you're going to be able to state is a sentence, and you're going to write what you're going to state mathematically, and then you've got to provide a reason why. This is using deductive reasoning. Okay, we're going to go through the theorems while we do our notes, and so I'm going to save these theorems. Notice that the pages are provided for you. I want to make sure that you write down these theorems on these pages that are provided, and that's it. I just wanted to give you some symbols for your vocabulary packet so you know how to write them. All right, you guys have a great day, and I will see you in class. Bye.